So now we took an op amp and instead of a comparator now, we actually wired it as a voltage follower. So as our voltage divider voltage goes down, the LED will fade off right there. So it actually lowers the output voltage. And I have the LED wired to light up when the output is given as positive of a voltage as it can. Of course, it falls short of the positive supply voltage because it's an LM358. And so it falls short of the positive supply, but can go all the way down to ground right there. So we have our voltage divider right there with the light dependent resistor with the LDR on the high side, so more light equals a higher voltage. We have the output tied to the inverting input because that's the way you make a voltage follower. In that way, the op amp will do what it can to get the output voltage to be exactly the same as the input voltage. So now, an op amp voltage follower is a very simple circuit. First off, you have that voltage that you want to output. Now, you don't want to power a load with, in this case, this voltage divider because they cannot provide current. That throws off the voltage. And so you send it to the non-inverting input right there. More light will give you a higher voltage, and then when it is darker, the voltage will go down right there. But you got a voltage divider. So the way that you get the output to get the same voltage as the non-inverting input is just to feed back the voltage directly to the inverting input right there. The output always wants to be more like the non-inverting input than the inverting input, and when they are the same, then it's really happy. It's going to lock into place right there, whatever voltage that may be. Now, you can power light loads with that output as well at that voltage. So now, of course, you have to power the op amp, and I'm this far away for those that watch shorts, because that's most of my viewers these days. So, in any case, I did not add the power pins. Usually you see them right there. Of course, you always have to power the integrated circuit. And you definitely need that power to output the power there. That's where it connects. But here I did not add it because a lot of schematic diagrams do not add them. But you always have to power them. Be aware of that. So yeah, here you can see when you actually wire up, no matter what's on the schematic, you need the positive supply to pin 8 for this op amp. And then negative supply to pin 4 over there for this particular op amp. Other op amps have different pin layouts. That's why I say that so much. And I got jumpers there. Positive connects to positive up there, and then negative connects to negative over there. So both supply rails have the same voltage source. So now we're going to make a short about the inverting input. That's why I'm so far away right here. Now, the inverting input. It looks at the voltage applied to it, and that's it. It tells, though, the output what that voltage is, for the most part. So in any case, the output wants to be more like the non-inverting input than the inverting input. So when you connect them directly together, then the output will know it's at the same voltage when both inputs are the same voltage, right there. So that's all it knows. It can raise or lower its voltage, but it just wants to stop once they are both the same voltage. Hopefully that makes sense. So we come over, and there you can see we got the output, the top left pin right there to the inverting input. Right below it is the inverting input, and then below it again is the non-inverting input, where we are giving our signal voltage, which we will cover next. So now, we're going to look at the signal voltage, which goes to the non-inverting input right there. Output always wants to be more like the non-inverting input. And the reason why we're doing this is because a voltage divider is not meant for powering a load, even a light load like an LED. So instead we give it to the op amp. And it's pretty straightforward. You just get a voltage set to the non-inverting input right there. More light on a light dependent resistor, it'll get closer to the supply voltage it's going to. You get a higher voltage. When it gets darker, voltage will go down. And output's going to do what it can to equalize those two voltages, so it goes up and down accordingly. And usually an op amp can provide more power to a load. You know, not always, but in this case it can. So we got the positive there, and then the fixed resistor down low. They're connected together there. They're going down to the third pin on the left, which is the plus or the non-inverting input. So now, I like to end my video, which is the last short for these videos where I make shorts, with what the load is doing there. So I just have a single LED here. We could also have a blue LED to alternate which one's brighter, but I didn't add that. But in any case, 220 ohms protecting the red LED from 5 volts, although when we're powering it with 5 volts, again I didn't show it, but you have to power it, it falls short of the positive supply voltage by about a volt or so. But we got the red LED. Make sure you put it in the right way. And 220 ohms, again, we don't have a lot of voltage to work with, so we kind of want a decent amount of current. But yeah, there you can see. We got the output top pin tied to the inverting input. It's also powering a load, which we can do there. And it got LED got dimmer because I started covering the light dependent resistor. And so it's that simple. So that's it. Thanks for watching.